Welcome class, this is Math 1440, section 8.5. We're going to go over this one long problem. Minimize this function in two variables, x squared plus 4y squared, subject to the constraint xy equals 1. So in the real world, there's many constraints. Like for example, there are budget constraints, or you may want to minimize the surface area of a soda can, but you want to have the constraint that it holds 12 ounces. So this type of problem is important because it applies to the real world. And we want to find this minimum by using the method of Lagrange multipliers. Lagrange is a French mathematician. He's the one who came up with this unbelievable method. Okay, so here's our solution. What we want to do is solve the constraint equation xy equals 1 for 0. So in other words, get that 1 on the other side. So we're going to subtract 1 to both sides of this equation, and we get xy minus 1 is equal to 0. So now that 0 is on one side, the left-hand side is what's known as g of x comma y. So g of x comma y is the xy minus 1. Now we can form what's called the Lagrange function. The Lagrange function is capital F to denote a difference from smaller f. Remember, this is our original function. Little f of xy is equal to this function. So what you want to do is form a new function, the Lagrangian function. So f of x comma y, and now we're going to introduce a new variable, lambda. Lambda looks like an upside down y. So here is how this new function is defined. It's going to be the given function f of x comma y plus lambda times g of x comma y. And again, this is called the Lagrangian function. Now that we have the Lagrangian function, the next step is to find the partial derivatives. So next, find the partial derivatives, which is denoted f sub x, f sub y, and f sub lambda, and set to 0. So set each one of those equal to 0, those three equations, and then you want to solve that system of equations. And that will give us our critical points. So the partial derivative of f with respect to x is 2x plus lambda y. How did we get that? Well, let's go right here. F of x, let's go back to the Lagrangian function rather. The Lagrangian function is capital F is the Lagrangian function. Here it is. So if I take the partial derivative with respect to x, this becomes a 2x. This becomes a 0 because there's no x. And if you distribute this lambda, you would get lambda xy. So the derivative of that would be just the lambda y. That's the constant being multiplied by x. Okay, so that's how we got that partial derivative, 2x plus lambda y. And then similarly, you should verify this. The partial derivative of f with respect to y is 8y plus lambda x. And then the partial derivative of f with respect to lambda is xy minus 1. And let me show you how that was gotten. So lambda is right here, and it's being multiplied by the xy minus 1. So the derivative with respect to lambda is this constant factor, xy minus 1. The other terms have no lambdas, so these are like constant terms where the derivatives are 0. So 0 plus, and then xy minus 1. That would be your f sub y. So there it is, x sub y. Okay, now that we have those partial derivatives, we want to solve this system. And this system's a little bit involved. We got a system of 3 equations with 3 unknowns. So let's take a look at what the plan is. For this particular system, each system is a little different. We're going to solve the top equation for lambda and substitute it into the second equation, etc. So let's go back to our system. So the top equation, I'm going to solve it for lambda, and then whatever I get, I'm going to replace this lambda with that expression. And then I'm going to have an equation with just x's and y's, and I want to just get one variable. So what I'm going to do is solve this third equation for either x or y. It doesn't matter. And that way I can substitute that back into this equation here. So this sounds a little bit confusing, but it's not bad as it sounds. It's not that bad. Okay, so let's solve this first equation for lambda. So let's subtract 2x to each side and then divide by y. So here I go. So from the top equation, we're going to get lambda y equals a negative 2x, and then divide by y, and there's our value of lambda, negative 2x over y. So now what you want to do is rewrite the second equation with that substitution. So here's what the second equation becomes. So let me just show you the second equation. Sorry for all this camera work up and down. So there's my second equation. We're going to replace that lambda with what we just said. So here we go. Except from the second equation, we get 8y plus, instead of writing lambda x, we're going to write negative 2x over y times x, and that equals 0. And then what I want to do next is clear the fraction. So multiply both sides by y. So when I multiply both sides in y, this implies 8y minus, okay, let's do it now. Multiply both sides by y, now that we got 0 on one side. So we get 8y squared minus 2x squared equals 0. Let me show you that again. When I multiply by y, this becomes 8y squared. Here the y in the bottom cancels out with the y. And anything times 0 is 0. So there we have. So now notice I got one equation. I got one equation with two unknowns. I only want one unknown. Right now I got a y and I've got an x. So let's see what we did next here. I divide everything through by 2 since everything is even. So dividing by 2, I should get 4y squared minus x squared equals 0. And that's exactly what I have. And now what you want to do is work from that third equation. So from that bottom equation, the third equation or the bottom equation of xy minus 1 equals 0, let's first add 1 to each side to get this. And then I solved it for y by dividing each side by x. So when I divide each side by x, I get y equals 1 over x. That's a 1. Sorry, it's a little faded. 1 over x. So now that I know y is equal to 1 over x, we're going to substitute it into that y from the second equation. So substitute 1 over x for that y. And that will allow us to have one equation and one unknown, which we can do. So here's what we get. 4 over 1 over x squared minus x squared equals 0. Next, let's square the fraction. You square the numerator and you square the denominator. So it's going to be 1 squared, which is 1, over x squared. So 4 times 1 over x squared minus the x squared equals 0. Think of 4 as 4 over 1. When I multiply, I get 4 over x squared minus the x squared is equal to 0. Let's clear the fractions. Whenever you have an equation, meaning an equal sign, you're allowed to multiply both sides by the LCD, as long as that's not 0. So x cannot equal 0, otherwise you're dividing by 0. So the domain is going to be all x except for 0. Okay, so when I multiply both sides by x squared, I get 4 minus x to the 4th is equal to 0. This is a difference of 2 squares. This is a difference, minus, of 2 squares. So that's going to factor as the square root of this minus the square root of that times the square root of this plus the square root of that. Remember, this is like a squared minus b squared equals 0. And it factors as a plus b, a minus b equals 0. So this is going to imply, so the square root of 4 was 2, the square root of x to the 4th is x squared. So let's write 2 minus x squared, 2 plus x squared, or vice versa, equals 0. And now we use the 0 factor rule, set each factor equal to 0. So we want to solve 2 minus x squared equals 0, and 2 plus x squared equals 0. But this is impossible, because x squared at the very lowest is 0. X squared is never negative. So 2 plus 0, or 2 plus a positive number, is never going to equal 0. If I subtracted 2 from each side, by the way, I'd get x squared equals negative 2. Impossible! So there's no solutions for that second equation. That's why I struck it out. Okay, so from here, let's add x squared to each side. So you can either write 2 equals x squared or x squared equals 2. Same thing. Symmetry of equality. So now I just took the square root of each side. Don't forget to go plus or minus. So x is equal to plus or minus the square root of 2. Now that I found x, let's substitute for y. So previously, over here, we had y equals 1 over x. Let me make that one a little darker. So we found previously that y is equal to 1 over x. So if x is plus or minus the square root of 2, so let me go down here. And since from above y equals 1 over x, we get y rather, is equal to 1 over the square root of 2, comma, y equals 1 over negative the square root of 2. Because y was equal to 1 over x. And don't forget, for x, we got plus or minus the square root of 2. So in place of this x, I wrote the square root of 2 to get one value for y, and then I wrote negative the square root of 2. So the other value of y is 1 over negative the square root of 2. Okay, so let's see where we are here. So, and since from above y equals 1 over x, we get these y values. Thus, here come our points. where we achieve a minimum. So square root of 2, comma, and then I've rationalized the denominator. Look what I did here in the red. So we had 1 over the square root of 2 as our value of y, but I rationalized the denominator by multiplying by an expression of 1. The square root of 2 over the square root of 2. Isn't that another name for 1? And now when I multiply the numerators, I get the square root of 2. And then the square root of 2 over square root of 2 is just 2. So this is called, we just rationalized the denominator. Isn't our denominator no longer irrational? So that's not a big deal. But it's nice to simplify like that. So that's called rationalizing the denominator. So in summary, to get the minimum value though, okay, so this, I'm sorry, this would be my two answers. Where, like if the question was, where does the minimum occur? It occurs at these 2 points. And then if they want to know what is that minimum value, we plug in these points one at a time into our original function in the problem. This is our original function. So if I plug in our x and y into this equation, I'll get the height or the output, which is the value. So to find the actual minimum value, here's what you do. You just plug in the points. Okay, so these are my points. And those points are going to be where f is minimized. And now to get that minimum value, plug in those points. Square root of 2 for x, square root of 2 over 2 for y, and negative square root of 2, negative square root of 2 over 2 is my other point. And we want to plug them into the original little f of xy, because this is our function. This is going to be the graph of our surface. And where is the surface going to be at a minimum? It's going to be at those 2 points. And what is that minimum value? Well, when you plug in x is the square root of 2, when you plug in x is the square root of 2 and y is square root of 2 over 2 and do the arithmetic, you're going to get 4. And likewise, you'll get the same answer for the other point because these are even functions. So if y is positive or negative, you're going to get the same output. So in both cases, you can try it at home. You should get 4 for your output. So in summary, and this is our final part, the function evaluated at this ordered pair is 4, and the function evaluated at our other ordered pair is also 4. So the minimum value is 4, but where does the minimum value occur? At those 2 points, square root of 2, comma, square root of 2 over 2, negative square root of 2, comma, negative square root of 2 over 2. So if you have questions with this, feel free to visit me during office hours. That's probably the best way to understand things, because that way we can see each other and we can talk about whatever your particular concern is. Or you can always email me as well. Okay, so that's it for today. Have a good one, everyone. Bye-bye.